So this is without this. Okay.
Okay.
So remember how I said this is like impermeable to water?
Mm-hmm.
Okay. So antidiuretic hormone. So diuresis is basically like the loss or excretion of fluid, right? And so antidiuretic hormone would basically mean like water retention, like you want to hold on to water.
It's like not leaving it.
Yeah, yeah.
Okay.
So the way this works is because this is impermeable to water, water can't pass through. But there's these proteins called aquaporins, and they're
Blood channels, right?
yeah. And so they basically put channels in the distal convoluted tubule, maybe I think somewhat in the ascending loop of Henle,
Mm-hmm.
so that water can then go back into the blood. Right.
So that water can leave?
Yeah, so because water going this way, this means leaving the body, right? And so if we want to retain water, we want to not let it leave the body. So we want it to bring it back into the blood.
Okay.
Because one of the purposes of antidiuretic hormone is to control blood pressure and specifically to raise blood pressure, right?
Mm-hmm.
So one way to raise blood pressure is by increasing blood volume, and the easiest way to do that is to add water, right? And so as we add water, or add the antidiuretic hormone basically activates these channel proteins to go to the surface and allow water to pass through,
Okay.
so that we can hold on to more of that water. Okay?
Yeah.
So
So ADH is released in the distal, right?
well,
Or
antidiuretic
just-
hormone is released by the posterior pituitary, but this
Well,
is where it activates.
where it happens.
Yeah, this is the target, right? Okay, so so with ADH,
So is ADH always present, or like
No.
does the water just flow out?
yeah, so when ADH isn't present, that's like what I had before, like
Okay, yeah.
water not
It just
coming back in.
come
So for example, and ADH is also affected environmentally, like for example, if you were like in the desert or in the heat,
Mhm.
your urine production would drop, right? Because
Yeah.
you'd want to not waste water because you'll need water. So your body would probably release some antidiuretic hormone so that you retain more water. But
So it's not normal that the water goes back in the blood, or?
it just depends on
Okay.
what state you're in.
Mhm.
Like if you're drinking a ton of water and you're like really hydrated,
I'll try and push it.
probably you're not going to be producing as much ADH, and your urine will be very dilute, right? It'll have a lot of water in it. But with ADH, it says like about 1% of this initial filtrate that went through the glomerulus is actually leaving the body.
Oh, okay.
Does that make sense?
Yeah.
So it like really drops your urine production, right? So yeah, but I couldn't find what the percentage is without ADH, because because this kind of, in your book, is a really good picture. I don't know if you have this one. Yeah, this kind of puts it all kind of in a nutshell, right? It explains like kind of what's going on. Yeah, and it gives you like kind of percentages, like
Okay.
a lot of water actually leaves like immediately from the proximal, right? And
That's what I was gonna ask. There was like, I think there's a percentage my teacher was talking about with, like during filtration, that there's like, I want to say like 99% is filtered or something.
Yeah, so, well, back when we were talking about glomerular filtration rate, right, it's only 19% of the, well, let's see. Yeah, 19% of the plasma is actually filtrated,
Okay.
right? Maybe that was it, but because like yeah, right here, this is like 19% of the plasma that passed through here is actually filtered. kind of makes sense. So,
Mm-hmm.
but yeah, that's basically a general outline of
Yeah, that really
the
helped.
nephron and stuff. But
Are
now
all-
it's kind of like, so why is this all happening, right?
Okay.
And he'll kind of I'll kind of briefly introduce this, but so, gosh, how am I gonna do this? I'm gonna use one of my own markers so I have a different color going on.
Are aquaportin channels, are those just for like helping release antidiuretic hormone, or
Well,
it's just for-
antidiuretic hormone activates the
Yeah.
aquaportins, right? So, yeah. So without ADH, these aquaporins won't let water
Do they
pass
do
through.
anything else, the channels?
No. No. They're kind of specific to just water. So, okay. So, let's see if I can draw this right. Okay. So, basically, wait, hold on, is this efferent? Okay, so let's say this one's the afferent and this one's the efferent. It doesn't matter which one's on the top or the bottom. Right, so this is the blood coming in, this is blood coming out, right? And so this kind of goes like this. So it kind of goes around here, and then it drops this way, it comes this way, and then out to the body, right? This is the direction of the blood flow, right? So you notice that the filtrate is flowing the opposite direction as the blood, right? And so this is kind of one of the things that explains why what's going through is happening, right? So basically, so right here we've got like solutes coming into the blood and water coming into the blood, right? Solutes leaving. And then right here we've got a lot of solutes coming into the blood, right? But eventually we want it to be water coming into blood, solids going out, that goes to the rest of the body, right? Because we're wanting to get rid of excess solutes and stuff like that. And so, like, that's why this happens here and it's not reversed, because we want the water, we want there to be a good amount of water in the blood, right? And then we want there to be a balance of solutes. And so the solutes will leave the blood and water will come in as it leaves and goes to the rest of the body. Does that kind of make sense?